Hello, geometry students. Welcome to lesson 10.4, areas of regular polygons and composite figures. This lesson is going to be a little meatier. This one's going to take a bit longer. There's more to it. Definitely have your calculators handy so that you can follow along doing the calculations in your calculator, making sure you get the same values as I do as I work through this. So this one of the harder ideas we're going to encounter in this chapter, finding the area of regular polygons, but it's going to be a process that I think totally makes sense. The idea is not a hard idea. You just have to remember some things from a previous chapter when we did our trigonometry chapter. That's going to come into play here. You, in some cases, can also use 30, 60, 90 triangles or 45, 45, 90 triangles to help you do some calculations. But if we were trying to find the area of this regular polygon, regular means, remember, that all sides and angles are the same. There's a handy formula we can use for that, but I want to talk about where that comes from. So let's take this and split it up into some different triangles. What on earth is going on there? So I think I'm just going to draw these out. That was a very strange thing that just happened there. I wasn't trying to have like a double-sided lightsaber come out of that point. I was just trying to draw a single one. Let me try to do that again just to see if that happens one more time. Yeah, that is very strange. So I'm not going to use that functionality, it looks like, of the program here. Not sure why that's going on. But if we split it up into 5 triangles, I'm going to focus on this blue one down here, but you could also be looking at that, and that here. If you want to use a ruler for this, that might be a good idea based on what you just saw there with the line like just coming out in both directions. I'm not going to be able to do that here, so I'll just have to sketch or freehand as best I can. But from here, if I found the area of this triangle and I multiplied it by 5, 1, 2, 3, 4, 5, that would give me the area of this regular pentagon. It'd be what I need to do to be able to figure this thing out. That is the basic idea. So if you take a regular polygon with any number of sides, split it up into the number of triangles like you see here. So if it's a hexagon, there's going to be 6 triangles that are congruent to each other, heptagon 7, and so on, and then find the area of one of those triangles and multiply it by the number of triangles you have. That is the formula that we're looking at. So I'm going to leave some space up here for some calculations, also some space down here for some calculations, but I'm going to write this as our general formula. So the area of a regular polygon is going to equal the area of one triangle times the number of triangles you can make. So I'm going to use parentheses here and here just to hopefully make it a little easier to follow as we're going through this. I might circle this if I were you, or highlight this. This is the formula, and the way from here on out I'm going to use or write the formula to help calculate some other problems we're doing. But I'll show you a couple different ways that the textbook also shows it in the next slide. But from here on out, I'm going to refer back to this most frequently throughout this lesson. So let's take a look, though, at this triangle right here. So I'm going to split this up to 2 pieces. To find the area of any triangle, it's 1/2 base times height. So if I knew what the base was, which I do in this case, it's 3, and I knew what the height was, I don't know that at this point, so I'm going to label it with an H. Then I could find the area of this triangle, just multiply that by 5, and I'll have my answer. So to do that, I'm going to need to figure out H. How do I do that? How do I figure out H? Well, it looks like we have a right triangle, and if we knew one of these 2 angles, we could figure out anything else here. So this is going to be 1.5 right here. And I'm going to be focused on, and you might want to highlight this yourself, I'm going to be focusing my attention on, let me make that a little smaller here, on this triangle right here. That is a triangle that I'm doing some calculations with to figure this stuff out. So this angle right here is going to be, well, it's a regular pentagon. So if we did 360, that's all the way around, and we divided it by 5, that would give me from here to here. And then I'm splitting that in half with this altitude being drawn in there. So the idea is we're taking 360, dividing it by 5, which is the number of triangles in this case that we had to start, and then splitting that in half, dividing that by 2. So you may want to write something like this down in your notes, 360 all the way around. That's why 360 is there, and then 5 is the number of triangles. We have 5 triangles that we initially split this up into, and then the 2 is coming from the fact that we're bisecting the angle. So doing all that, 360 divided by 5 ends up being 72. 72 divided by 2 is 36. So that angle right here is a 36-degree angle. So really what I'm looking at right now, if this helps you to draw a separate picture, feel free. That's 36, that's H, that's a right angle, and that's 1.5. We are solving for H using trig at this point, SOHCAHTOA. So remember SOHCAHTOA? I hope you remember it. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. In this case, looking at this triangle, we have no information about the hypotenuse, and we don't care what it is. We don't need to know what it is, but we do know the opposite value from 36 is 1.5, and the adjacent value sharing a side with that angle adjacent is H right there. So if we take that and apply that to this problem, I'm going to use purple for that. So I'm looking at this, or I'm looking at this orange triangle. You don't need to draw that if you have all the information you see here. We're looking at a tangent problem. We have opposite over adjacent. That's the TOA part of SOHCAHTOA. So tangent of 36 degrees is going to equal 1.5 over H. And now from there, I could put this over 1. I can cross multiply from there to get what H is. So I've got H times tangent of 36 would equal 1.5 if I cross multiply. And then I can divide by tangent of 36 to get what H is. I have H by itself at this point. So I have 1.5 over tangent of 36. That would be an exact answer. You could actually plug that into the formula if you wanted to. However, I'm going to use the approximated form of that. This is what I was mentioning in 10.3 and even a little bit in 10.1, 10.2 if I recall correctly. This is where I definitely want to use a significant number of decimal places. I don't want to round too much right now, because if I do that, when I multiply it through, it's that rounding error is going to become even more exacerbated, and we'll have an even bigger issue than we would have. So if I round, and my plan for this, what I want you to do if you're one of my students, is to use 5 or more decimal places if you're going to use a rounded answer. If you're going to plug this in exactly, be my guest, that's going to give you the best possible answer. I think I need some water. I'm not feeling sick. I just think I need to go grab some water here in a second. But area of a regular polygon, we are looking at one triangle, area of one triangle. So I'm going to do 1/2 BH, and I'm going to write the formula out in general as I am doing this. And then the number of triangles that I have in this case, those initial triangles I drew, there were 5 of those. So I'm going to do 1/2 base times height times 5. And so 1/2 times the base. The base of this whole triangle was 3, so I'm going to replace B with 3. The H is right there, so the H is going to get plugged in into the formula in this step. So I'll use purple to do that since I'm taking that purple value. So 2.06457. And then from there, everything else is the same, so times 5. Notice this is all one big string of multiplication. So at this point, take your calculator, plug it in. If you keep this value in your calculator, what you had here, you can just hit, on most Texas Instruments calculators, you can hit second, and then above the negative button or below that is the ANS. So it's going to take your previous answer and plug that in. Or you can even highlight the previous answer, hit enter, and it will enter that into your calculator for you. That's the best way to get, I think, the best possible answer on these. So if we're going to take this, multiply it through in a calculator, I end up getting 15.48430. That is the value I got by keeping the answer in my calculator and just using the calculator to help it do the work, or have it do the work for me. So rounded off though, if you round it off to 5 decimal places, you should get something very close to this still. And then rounding to 1 decimal place, let's go nearest tenth for some verbal directions on this one, 15.5. If you took this as 2.1 or much worse 2 and just plug that in there, you're not necessarily going to get the right answer. You're going to be off by too much to be an acceptable rounded value. So 15.5 meters squared rounded off to the nearest tenth would be the best possible answer we could get on this one. So this idea, regular polygon is one triangle times the number of triangles. That's the way I'm going to progress as we do more problems like it here. But you could, and I want you to be at least familiar with the terminology that you might see in the book. If you're using the book extra examples, as I hope you are, to think about or look at some more problems that will help you understand these concepts, then I think you're doing a really good thing here. But they call this in the book, you're going to see an A for something called apothem. So if a regular polygon has an area of A squared units, capital A, and a perimeter of capital P units, and an apothem, A-P-O-T-H-E-M, there we go, of A, lowercase a units, then you're going to have this formula, 1/2. And you can do base times height of each triangle, but if you did the perimeter, if you do all the bases together, that'd be the perimeter. That would do all of these triangles all at the same time. So then you could just do perimeter times height, but perimeter would do all 5 triangles at the same time. So this is the most simple way to write a formula that works, or the most concise way to write a formula that works for this kind of problem. So if you prefer to use this as your formula instead of this formula right here, one triangle times the number of triangles, be my guest. There's nothing wrong with that at all. That is a way I've taught it in the past, but I feel like this makes the most sense to the most students, so I'm going to use that as we progress. But feel free to use that if you like that better. A is really equivalent to H in this triangle. The apothem is equivalent to the height of this triangle. And then if you're looking at B, that is going to be equivalent to the side length. So we're going to use that in this next version or way I could state this formula. And so since the perimeter is equivalent to the number of sides n times the side length s, you could rewrite this formula in one other way that some students in the past have preferred to use. So 1/2 s times a times n. So this is like 1/2 base times height. You can see in the picture here, s is equivalent to b in this triangle, a is equivalent to h in this triangle. So this is 1/2 base times height times the number of triangles. Again, that's just a different way to write the formula. If you prefer that, go ahead. If you prefer that, go ahead. If you prefer this, go ahead. Any of those 3 ways to write it, whatever makes the most sense to you, please use that. So in this case, for example 2, let's work through this one now. We've got the area of this hexagon is going to be equal to the area of one triangle times the number of triangles. Again, it's the same as this idea. We'll get the same answer for you. This idea will get the same answer for you. They're really the same thing, just written in a different way. So times the number of triangles here. And this one I know the perimeter is 96. So the work I'll do off to the side here would be perimeter, would be the number of sides times the side length. I'm using this idea here. And then I'm going to split this up into triangles. Here we go, there and there. And then you could be thinking of these other ones as well. How many of those triangles are you going to be able to draw? There's 6 of them, but I'm going to focus my attention on this blue triangle, and I'm going to split that in half as I did before. And then I'll highlight this part here. So I'm going to focus my attention on this orange highlighted piece of the triangle. If I can find what I need to from there, then I can plug it into the formula and figure out what the area is of the whole thing from there. So perimeter, number of sides times the side length, I've got 96 as my perimeter. Number of sides is 6, and the side length is unknown, so I'm going to call that S. That's not a 5, that's an S. So from there, I could divide by 6 on both sides, and that would leave me with 16 as the side length. So each one of these side lengths is going to be 16. 16 times 6 gives you a perimeter of 96. And S is the same thing as B if you want to think about it that way. So from here to here is 16. And if that's the case, that means this is going to be 8 right here, and that would also be 8. And this height is unknown. Why don't I label it with an H? So from there, I need to figure out what's that angle right there. So let me point to that. And if I did 360 divided by 6, the number of triangles I have here, and then split that in half since I bisected that angle, that would give me a value of 30 degrees. 360 divided by 6 is 60. Split that in half, you have 30. So guess what? You've got a 30-degree angle here. You've got a 90-degree angle here since that's 90, and that makes that 60 degrees right here. So you have a 30, 60, 90 triangle. So let's do this light blue. I'll do my ratios here. So 30, 60, 90 triangle, the hypotenuse would be 2n. This long leg would be n root 3. And this would be n right here. So if you think of the ratios that we learned about when we did special right triangles, that's the most efficient way to do this. You could still use trig if you wanted to. You could say tangent of 30 equals n, which is 8, or I should just say 8. Tangent of 30 equals 8 over h, and you could solve for h from there. But if you think of it this way, I think it's even easier. So if this is n, 8 is n, that means n root 3, which is equal to h. H is going to equal 8 root 3. So we can just use that value and the fact that the base here, this is going to equal B right there. 16 is equal to your base length, and plug those values into the formula. So you have 1/2 base times height for the area of one triangle times the number of triangles. In this case, we started off where we had 6 sides. So you could use this and this if you wanted to as well. If you're using this version of the formula, 1/2 times perimeter is 96 times the apothem is equal to h right here. So if you prefer to write it as a, think of it apothem and using that formula. A is the same thing as h. It would be 8 root 3. So you could plug that in right there if you wanted to, 1/2 96 and 8 root 3. Or you could say 1/2 and then 16 times the apothem 8 root 3 times the number of sides 6. Those formulas are going to give you the same value as what I'm getting here. So we've got 1/2 times 16 times 8 root 3, all that times 6 triangles that we made. So at this point, I would say yes, use a calculator to figure this out, but don't multiply by root 3. You should be able to get an exact answer for this. So half of 16 is 8. 8 times 8 is 64. And then 64 times 6 would be 384. So you'd have 384 times the square root of 3 millimeters squared on this one. Perimeter was millimeters, so area is going to be millimeters squared. That would be an exact radical form, simplified radical form answer of this. From there, if it said you could round, we could just write this and go right to this answer. So 665.10571 would be to 5 decimal places and to nearest 10th 0.1. That is not 5 or higher, the 0, the digit after the 1. So that would be a rounded off to the nearest 10th answer. Continuing on with one more problem like this, but this time integrating the area of a circle formula into an idea like this. So find the area of the shaded region. Just this yellowish part here is what we want to find. I'm just going to draw one of these triangles this time around. And so this time I'm going to be focusing my attention on that particular triangle here. And I'll highlight that as I have been doing so far on the previous two. So I'm going to be looking at this triangle right here to try to figure out what the height is and what the base is. And this one, we know the diameter of this whole circle is 14. That means this from here to here would be 7. The radius of the circle would be 7. But any radius would be 7. So would that. That would be 7 as well. And from there, we'll need to figure out, well, what's that angle measure? And then we can figure out this base and height from there. So the basic idea, or the big idea on this one, is that the area of the shaded portion is going to equal the area of the circle minus the area of, we're assuming the polygon is regular, you count up the sides, you've got 8 sides. So this is going to be the area of the octagon. So the first thing, or one of the first things I should see somewhere, is that you're figuring out what's that angle. So if we do 360 divided by the number of triangles we could make like that, that'd be 8 of them, and split that in half, we're bisecting that angle, so divide by 2, and you'd have 22.5 as your degree measure for that angle right here. This highlighted triangle, we're looking at that angle is 22.5. And then I'm going to call this H for height. If you want to call it A for apothem, that'd be fine. And then I'm going to call this X. And from there, I would have X here, and I'd have another X here. 2 X's would make up the whole base right there. So whatever X is, I'm going to multiply by 2 to get what the base length is from there. So from here, if this helps you to draw the triangle, again, this is the highlighted triangle. This is 22.5 degrees right there. This is your H, and this is your X. That's 22.5, H and X. So if we do that, it looks like, thinking of SOHCAHTOA, we're going to use tangent. No, we're not going to use a tangent, sorry, because this is 7. This is a known quantity. We couldn't use tangent because we'd have 2 variables with one equation. We couldn't solve for the numeric value of one of those by doing that. But if we used, and let me write SOHCAHTOA down again here. If we did use sine, that would be opposite x over hypotenuse, 7. So it looks like that's something we can use to figure out x. If we use cosine, that would be adjacent h over hypotenuse, 7. So we'll use both sine and cosine, but not tangent on this one to figure out some of the values here. So I'm going to go purple for a little while here. I'm going to figure out x by doing opposite hypotenuse, sine. So I've got sine of 22.5 equals x over 7. And this one, the cross multiplication works out nicer than before because we're not having to divide by something else later. So x times 1 is x. This would be 7 times sine of 22.5. And that here, 2.6878. Remember to make sure your calculator is in degree mode and not radian mode. I'm messing that up there. Sorry, this should be 2.67878. There we go. And that I'm going to leave just like that for now. If I take 7 times sine 22.5, leave what I get in the calculator, and then take that value and multiply it by 2 to get what b is. Remember, b is going to be 2 x's. If we look back up at this picture, x plus x is what the base length is of that triangle. Then it would give me 5.35757. If you just take this and multiply by 2, you're going to get a 6 here at the end instead of a 7. So it's best to leave everything in the calculator and just keep going that way if you can, but that's what your base is. I don't think, though, if you at least take this to 5 decimal places, and that becomes a 6, and then you plug it in, as long as you're going 5 or more decimal places, that's enough accuracy for my students at least. We're at least at this point not working for NASA, so that's enough levels of accuracy or significant digits for what we're doing here. So then cosine 22.5 is going to be what I would need to figure out what h is. So cosine is adjacent over hypotenuse, so it'd be h over 7. You can divide by, or put this over 1, cross multiply. Think about that from there. That's what we were doing there as well. And you'd have h is exactly 7 times cosine of 22.5. And then that is approximately 6.46716. So I'm going to circle that as well here. And then now I'm going to take those values and plug them in up here. So the area of a circle is pi r squared. And then the area of the octagon is going to be the area of one triangle, which was 1/2 base times height, times the number of sides, which is 8. So I'm kind of skipping writing out the general part for that. I'm not writing down this right there, but feel free if you'd like to do that for your purposes on the notes here. This is pi times 7 squared. The radius was 7 from this picture, and then 1/2. And then base is right here, so I'm going to take this value and plug it in. So times 5.35757, and then times height 6.46716. That is all being multiplied by 8. And at this point, I will simplify what I've got there. So this is, I could have written approximately here too, because I did round these things off, yes, to 5 decimal places, but they're still rounded a little bit. So this would be 49 pi for the area of the circle in a pi form. And then this, I kept all these values in a calculator to as many digits as the calculator gave me, not just 5. And then I ended up getting this as my value for all of this multiplied together. So 0.59293. So if you take this and this rounded to 5 digits, and multiply it together by 1/2 and 8, you might get something slightly different here at the end. But we're looking for, I'm going to go to 1 decimal place of rounding for the final answer here. So as long as you're not rounding too much too early, then you should get the same approximate, to at least to the nearest 10th form answer as I do. So this would be that, 49 pi minus that approximately in a calculator. Make sure you're typing these things in the calculator yourself and making sure you can get these values yourself with the calculator that you have. And so rounding that off to the nearest 10th, 15.3 feet squared. Remember, that's the circle minus the octagon. That's giving you the shaded part, what's left over. We're subtracting or taking out that octagon out of the circle, in a sense, to get that shaded value. So that, I think, is the hardest part of this lesson, those 3 examples and the idea of finding a regular polygon. We'll wrap this lesson up with what I think are easier problems, composite figures. So we're going to find the area of composite figures. There's no just like single formula to do these things. It's just going to be a combination of formulas you already know. So in this picture, I'll do some highlighting here. I think that will be helpful for you to see what's going on. So in this picture, I'm going to look at this triangle, and I'm going to look at this rectangle down here. So I am to find the area of this figure, or this composite figure, which I'll abbreviate with an FIG for figure. It would be the area of that orange triangle up there plus the area of this rectangle. We're just putting the pieces together. We're putting the pieces of the puzzle, so to speak, find those separately and add them together to find your total area. So the area of a triangle is going to be 1/2 base times height. So I'm continuing to be in that habit, and please consider strongly doing the same thing yourself. Be in the habit of writing the formula out in general and then plugging in the numbers from there. 1/2 base times height for this triangle, and then a rectangle is just base times height. So for the base of the triangle, it would be 10 plus 10. Either write that off to the side somewhere, or you can write it right in the formula like that. Show me you knew that 20 came from 10 plus 10. And then your height would be 8 in this triangle from there to there. And it says up here, assume angles that appear to be right angles are in fact 90. So assume that it looks like a 90-degree angle. It is. And then the base and the height of the rectangle, this B and H could be different than this B and H. So just be careful with that. This is going to be 10 plus 10 once again. for the base of this rectangle, and the height is not the same as this height was. So the height of the triangle is 8, the height of the rectangle is 10. So I'm going to multiply that by 10. Now I can simplify this. I could write this as 1/2 times 20 times 8 plus 20 times 10. Half of 20 is 10. 10 times 8 is 80. So the area of the triangle is 80. The area of the rectangle, 20 times 10, is 200. So your final answer on this one would be 280. And no units are given, but I'm going to write the word units squared. If there's no units given, if you're one of my students, I'm okay if you just write 280 if it was a short answer for your response type question. On this next one, we've got, well, first you might think, well, how do I figure that out? That just looks impossible. But notice you have a rectangle, and then each one of these is a quarter circle. You put the 4 quarter circles together, and you're going to get a whole circle. So we are looking at the area of the figure on this one is equal to the area of a rectangle, the rectangle going around the whole shape here, minus the area of the 4 quarter circles. So if we look at the area of the rectangle, well, that's 3, that's 5. This would be 3 as well here. This is 3, this is 4, and that's going to be 3 there. So if you do 3 plus 5 plus 3, that's going to be 11. If you do 3 plus 4 plus 3, that's going to be 10. So from here to here, the whole thing is 11. From here to here, the whole thing is 10. Show me the work somewhere, either off to the side or embedded in the problem, if you'd like instead. So the area of a rectangle, base times height. The area of 4 quarter circles would be 4 times 1/4 pi r squared, instead of just pi r squared. But 4 times 1/4 is going to get you to just pi r squared. So I'd accept that if you went right to that and plugged in some numbers into that. This would be 11 for the base times 10 for the height of the triangle, minus pi times, and it looks like the radius of each one of these quarter circles is 3. So minus pi times 3 squared. This would be 110. This would be 9 pi. This would be an exact pi form answer right there. This would be in units squared. And if you were to round that off, 110 minus 9 pi in a calculator is approximately 81.7 units squared. So you've got exact or pi form right there, decimal approximate form to the nearest tenth right there. Let's look at 2 more examples and this lesson, then we'll be done. So on this one, I'm going to refer to this as shape 1. There's a couple ways you could, a few ways really, you could tackle this one. I'm going to call these though shapes 1, 2, 3, and 4. A square, it looks like here, which is just a special type of rectangle. We've got a triangle, we've got another triangle, and we've got a rectangle down there. You could look at this as a trapezoid on the top of the x-axis, and then another trapezoid on the bottom of the x-axis, and you could add 2 trapezoids together instead. You could look at the y-axis and then look to the left and the right of that, another 2 trapezoids added together. But I think most people, or most of my students in the past, have seen this one this way and just put those 4 shapes together. So I'm going to do it this way on this one. The area of the whole figure is going to be the area of, and I'll just do area and then circle the 1 because that's kind of how I have it up there. Area of 1, 2, and 3, and 4 all added together. So the area of 1, that's a rectangle, that's going to be base times height. The area of 2, that's a triangle, that's going to be 1/2 base times height. 3, another triangle, 1/2 base times height. And 4, a rectangle, base times height. These B's and H's won't necessarily all be the same values. We have to look at each shape individually. So on this one, we've got 3 times 3. For shape 2, we have this is 3 here, this is 3 here. It looks like this would be 3, and if we count 1, 2, 3, 4, 5 right there, this is going to be 3 down here and also 5 down there. So we've got, for shape 2, 1/2 times 5 times 3 for 1/2 base times height. For shape 3, 1/2 times 3 times 3 for the base and height, and then plus shape 4, 5 times 3. Put all this together, we'd have for shape 1, we'd have 9 for 3 times 3, and then you'd have 1/2 times 15 there would be 7.5 for shape 2. 1/2 times 3 times 3 would be 1/2 of 9, which is 4.5, and then 5 times 3, 15. Put together everything there, 7.5 plus 4.5 would be 12, so you'd have 9 plus 12 is 21, plus 15 is 36. So on this one we'd have 36 units squared for the whole thing. You may even notice that you could take a whole outside rectangle like this, and then subtract this triangle and this triangle from that. That's another way you could approach that. You might find other clever ways to approach it too, but I think the ways I described were the most common ways I've seen in the past where students have figured that out. On this one, you might be thinking, boy, that just doesn't look right, or that looks like something I can't figure out, but this should help. So if we draw in these and assume this blue line is right on that grid line, it looks like it's just a hair under, but assume it is right there. And then these are right angles. What kinds of shapes do we have here? We've got a triangle for shape 1, rectangle for shape 2, and a semicircle or half circle for shape 3. So we're going to have the area of the figure is the area of shape 1 plus the area of shape 2 plus the area of shape 3 on this one. So we've got 1/2 base times height for the triangle. We've got base times height of the rectangle, and we've got 1/2 pi r squared for the half circle. Normally a full circle is pi r squared, so this would be 1/2 pi r squared. So if we figure out what we've got here, this is 3 from here to here, another 3 there to there. The radius, it appears, from here to here would also be 3. And then this height of both the rectangle and the triangle, if we count, that looks like it is 6. So we've got 6 there and there. We've got 1/2 base times height of the triangle then would be 1/2 times 3 times 6 plus base times height of the rectangle, 3 times 6 plus 1/2 pi, radius is 3 for the circle. So 1/2 of 18 would be 3 times 6 would be 9, and then that plus 18 plus 9 times 1/2 is 4.5, so 4.5 pi. Exact form, combine like terms, the pi part keeps separate from the regular numbers, so 27 plus 4.5 pi would be an exact answer in pi form, units squared. If you put that or plug that into a calculator, you'd have 41.13717 rounded to the nearest tenth would be 41.1 units squared. The nearest hundredth, 41.14, because that's a 5 or higher. Nearest thousandth, 41.137, and so on from there. So this would be exact pi form answer, and this would be decimal answer rounded to the nearest tenth. Whew, good job getting through that one. There was a lot to cover there. Composite figures are, I think, a little bit easier, unless you had a regular polygon as part of the composite figure. That would be a doozy problem, but definitely one we should be able to handle. Don't forget, or hopefully you haven't forgotten your trig stuff, review some SOHCAHTOA, review those 30, 60, 90, and 45, 45, 90 sorts of special right triangles as well if you need a refresher on that. Hopefully you found that helpful. Feel free to send me an email if you're one of my students with questions, or comment on the video if you have any questions and you're not one of my students. Hope you have a great day, and I will catch you for the next lesson. Bye-bye.